Here's a neat physics problem for you. A meter-long copper wire is bent into an L shape, exactly 1/3 from one end, and hung from a smooth nail at the bend. What position will the wire assume? Take a moment and try to picture it. Pause the video, and see if you can figure it out before we solve it together. Alright, let's set the stage. The wire is uniform, which means every centimeter has the same thickness and mass. At 1/3 of its length, the wire is bent at a right angle. At this bend we place a nail, and that point acts like a pivot. Because the nail is smooth, the wire is free to swing until its center of mass rests directly below the nail. On the screen you can see the L shape, a shorter arm which is 1/3 of a meter, stretching horizontally to the side, and a longer arm which is 2/3 of a meter, hanging vertically downward. The nail sits exactly at the right angle, holding everything in place. Now the wire has two segments. Each segment has its own center of mass at its midpoint. For the short horizontal arm, the midpoint lies halfway along it, so that's at 1/6 of a meter from the bend. For the longer vertical arm, its midpoint is 1/3 of a meter below the bend. Now, because the mass is proportional to length, the short arm carries 1/3 of the total mass, and the long arm carries 2/3. Let's put XY axes through the bend, and then we use the formula of the center of mass to find the equilibrium positions for X and Y respectively. Doing the weighted average gives us X equals 1/18 of a meter, and Y equals 2/9 of a meter. In simpler words, the balance point is slightly to the left, and more downwards. Now for this bent wire to be in equilibrium, the center of mass must hang directly below the nail. That means if we rotate the wire by some angle, the line from the nail to the center of mass has to be vertical. Let's simplify further and look at the turn angle required. Now let's solve for the angle. Since tangent of theta is equal to opposite divide by adjacent, theta is simply obtained by solving for tangent inverse, also known as arc tangent. The arctan of 1/4 is about 14 degrees. That tells us that the longer vertical arm tilts just a little, about 14 degrees, away from the vertical line. And that's it, problem solved. The key idea was, the wire swings until its center of mass lies directly below the pivot. If this helped you understand, hit like, subscribe, and share this video with friends who enjoy physics puzzles. See you in the next one.